First lesson in algebra in this term. We have learned before how to solve an equation of the first degree in one variable, but today we will learn how to solve two equations of the first degree in two variables together. Before explaining this lesson, you must revise. When I said to you that I have 5x minus 2 equals 8, how to get the solution set for this equation? We can see that to get the solution set of any equation from the first degree in one variable, you must have the variable in one side. So we can see that it's 5x equals 8 plus 2. After that, we can see that 5x equals 10. Then divide by 5, so the result will be 10 divided 5, so the result will be equals to 2. So we can see that the solution set of these equations equal 2. After that, we move to another point. We learned how to get the solution set or graph the equation y plus x equals 5. And we said that we can get any ordered pair belonging to the straight line representing the relation y plus x equals 5 by having a table like this. This table contains x and y. We can suppose some values for x and get the resulting values for y, like 0, 1, and 2. After that, substitute for x equals 0, you will get y equals 5. Substitute for x equals 1, you will get the value of y will be 4. Then substitute for the value of x with 2, you will get the value of y equals 3. So we can see that the ordered pairs 0 and 5, 1 and 4, 2 and 3, belongs to the straight line representing the relation y plus x equals 5. Now, we will learn how to get the solution set of two equations having two variables from the first degree. Let's see the first example. I have a playground having length more than its width by 4 meters. If the perimeter of the rectangle equals, or the playground, because we have the playground in the shape of a rectangle, it's 28 meters. Find the dimensions of the playground. If I have a playground like this is the playground. I have here the center. So we can say that any playground will be in the form of a rectangle. This rectangle contains length and width. I have here the width and here I have the length. First, you will suppose that the width is x and the length is y. So we supposed that the width of the rectangle is x and the length is y. Here I have the playground having length more than its width by 4. So we can say that the difference between the length and width is 4. So we can say that the greatest is the length minus the smallest is the width equals 4. And this is the first equation. So it will be y minus x equals 4. After that, I have the perimeter of the rectangle equals 28. We know that the perimeter of any rectangle, it's p equals length plus width times 2. So we can see that the length plus width equals half the perimeter. I have the length is y and the width is x. So half the perimeter equals 28 over 2. So we can see that it's 14. I have here two equations. Number 1, y minus x equals 4. Number 2, y plus x equals 14. And this is the second equation. I have two equations. How can we find the solution of the two equations together? This is what we discuss in this session. Now we will learn how to get the solution set of any two equations from the first degree graphically. I have two methods to get the solution set of two equations in two variables from the first degree. Number 1, the graphical solution. I have the first example, L1, y equals 2x minus 3. And L2 represents the second equation, x plus 2y equals 4. Why we say L1 and L2? In the starting of this session, we said that any equation of the first degree in two variables can be represented by a straight line. So we can say that L1 represents the straight line that is formed by the equation y equal to x minus 3, L2, the straight line represented by the equation formed by the equation x plus 2y equals 4. And we said also that we can say that the first equation y equals 2x minus 3, we can get the 3 ordered pairs satisfying this equation by supposing that I have x and y. Let's have some values of x, get the values of x as you like. We can see that it's 1, 2, and 3. After that, substitute for the values of x in the equation and you will get the values of y. I have, when you put x equals 1, 2 by 1 equals 2 minus 3 equals negative 1. After that, when x equal or takes 2, so the value of y will be 1. When x takes 3, the value of y will be 3. So it will be 2 times 3, 6 minus 3 equals 3. So I have 3 ordered pairs or 3 values for x and y together. Now, we will get 3 ordered pairs also satisfying the second relation or the second equation x plus 2y equals 4. It's easy to you to get y in one side and all the equation in the other side. So we can say that from having 2y equals 4 minus x, you can say that y equals 2 minus half x. How can we get this? By dividing both of the two sides of the equation by 2. Now, suppose that you have some values for x and get the resulting values for y. Here you will suppose that negative 1 and 0 and 1 are values of x. Someone says to me, Mister, we can take some values for x like 4, 5, 7, 8 or great values. Okay, if you want to get small values or you want to get a drawing scale small or a graph not large, you can take some values for x near to 0. So don't go far from 0. Take some values of x that are near to 0. Like negative 1, 0, 1, 1, 2, 3, negative 2, 0, 2. Here I have negative 1 and 0 and 1. Substitute in the equation. This is equation. I have y equals 2 minus half x. When x takes negative 1, so it will be 2 minus half times negative 1. It will be 2.5 or 5 over 2. After that, when x equals 0, you will have this term will go and you will have the value of y will be 2. After that, when x takes 1, you will have 2 minus half, it will be 1.5. So what will we do next? After having some or 3 values for x and 3 values for y, in the first and the second, you will represent these values on the graph. I have the lattice. As you see, we divided the lattice into 2 parts. I have x-axis and y-axis. I have here 1, 2, 3, 4, 5, 6, and here I have the negative part. This is the positive part, and this is the negative part. Don't forget to write x and x dash, y and y dash. Don't forget to put the arrows on the graph. It's very important to have a graph ideal, or have an ideal graph for you. Now you will represent each one of the 2 tables alone. I have 1 and negative 1. So 1 on x and go until you reach negative 1 on y. So I have, this is the point. After that, 2 and 1. This is the second point. 3 and 3. This is the third point. When you put your ruler on these 3 points, you will notice that these 3 points lie on the same straight line, and this is what we want. We want to get the straight line representing the relation. Join between them, you will have a straight line that is representing the equation y equals 2x minus 3. So it's a straight line. You must put the arrows as we said. This is L1. After that, you will represent the second straight line, negative 1 and 2.5. Negative 1 on x, 2.5 on y. This is between 2 and 3. After that, 0 and 2 like this. After that, 1 and 1.5 like this, between 1 and 2. You will notice that the 2 straight lines the 3 points lie on the same straight line, you will draw the other straight line by another color like this. Make it more clear. You will notice that the two straight lines intersect at the point 2 and 1. So this is the point of intersection of the two straight lines. We can say that the solution set of two equations from the first degree in two variables represented by two straight lines is the intersection point between the two straight lines. As we see, we can say that the intersection point here is 2 and 1. So we can say that our solution set will be the set which contains the ordered pair 2 and 1. And it's important to put it between two braces of a set. Inside them you have an ordered pair. Okay, after that, let's move to another example. I have another two equations from the same type, y equal to x minus 4 and 4x equals 2y plus 8. I have the first equation, y equals 2x minus 4. As we said in the first example, you must suppose some values for x, then get the resulting values for y. We have x and y, -1, 0, and 1. As we said, take some values that are near to 0, like -1, 0, and 1. Substitute for the value of x, then notice the value of y. If you have x equals -1, 2 times -1 equals -2, and -4 will be -6. 2 times 0 equals 0, and -4 will be -4. 2 times 1 equals 2 minus 4 equals -2. So this is the three ordered pair satisfying the first relation. After that, I have 4x equals 2y plus 8. We can divide this equation by 2 because you have 4 and 2 and 8. So all of them can be divided by 2. And you can put it on the form 2x equals y plus 4. Then have y on one side, so it will be 2x minus 4 by having 4 in the other side. Also you have x and you have y. Then suppose that you have some values for x like -1 and 0 and 1. Notice the resulting values for y. I have y. From having x -1, you will have -6. After that, -4. After that, I have 0, so it will be -4. After that, having x equals 1, 2 times 1 equals -2. So this is -6, -4. Okay, I have 2 times -1 equals -2, -2, and -4 will be -6. So I have y equals 2x minus 4. After that, substitute for these values on the graph. Having the two equations, -1 and -6. So you will put the point here. After that, 0 and -4, you will put the point here. 1 and -2 will put the point here. Then join between them like this. After that, -1, 0, 1. Here I have -6, -4, -2. So you will have -1 and -6 also. 0 and -4 also. 1 and -2 also. So you will notice that you have the same points at the same straight line. So I have the first, second, third. So with this straight line, if you join between the 3 points that representing the second straight line, you will find that the two straight lines lie on each other. So we can say that they are represented by the same straight line. L1 and L2 have the same straight line. So we can say that they are coincident. So we can say that the two straight lines L1 and L2 are coincident. So we can say that the solution set equals the set which contains x and y as an ordered pair such that choose one of the two equations, y equals 2x minus 4. And in this case, you mentioned that the two straight lines are on the same straight line. So how can we get the solution set for the two equations? If you notice the two straight lines, you will find that they are coincident. They are lying on each other. So the solution set is any ordered pair on the straight line. So any ordered pair on the straight line is a solution for the two straight lines. Any point on the straight line is a solution for the two equations. Now let's move to another two equations. I have y equals 2x minus 2 and 2y minus 4x minus 2 equals 0. From the first equation, I have y equals 2x minus 2, and here I have x, here I have y. So let's have 0, 1, and 2. As you see, I am choosing some values for x that are near to 0. Don't go far from 0, as we said. I have 0, substitute, so it will be negative 2. After that, 1 will be 0, 2 will be 2. After that, the second equation, 2y minus 4x minus 2 equals 0, you will have 2y equals 4x on the other side, and negative 2 will go to the other side by positive 2, divide by 2 because you have a common factor between all the terms of the equation, so it will be y equals 2x plus 1. Then you have x and you have y. So you will choose some values for x, negative 1, 0, 1. Substitute, so it will be negative 1 times 2, negative 2 plus 1 will be negative 1. 0 times 2, 0 will be 1. And 1 times 2 equals 2 plus 1 equals 3. After that, as we said, go and represent these points on this lattice. So I have from the first, I have 0 and negative 2. So stand at 0 and go until you reach negative 2. After that, 1 and 0, like this. So 1 and 0 will be represented on x-axis because you will stand at 1 and don't move because you have the distance at y is 0. After that, 2 and 2, like this. Then join between the 3 points. Don't wait until you have the other 3 points. If you put the first 3 points, join between them first. So I have L1. After that, you will have L2 represented by the 3 points, negative 1 and negative 1. So it will be like this. 0 and 1 will be like this. 1 and 3 will be like this. After that, join between the 3 points using your pencil and make sure that you are using your pencil. At your copybook and at your exam paper, use your pencil because maybe you will have some mistakes. You can ignore these mistakes and erase it again. If you noticed these two straight lines, you will have L1 and L2. What is the relation between the two straight lines L1 and L2? As you see, we can say that the two straight lines are parallel because they have equal distances at the same points. When you have two straight lines are parallel, they don't intersect. From the definition of the parallel lines, two straight lines are parallel if they are not intersecting or if they have not intersection point. After that, the solution set of these two straight lines will be equals to phi. Why phi? Why phi? Because you don't have any intersection point between the two straight lines. And we said before, the intersection point between the two straight lines representing two equations in two variables from the first degree is the solution set. Because you don't have any intersection point, you don't have a solution set. So the solution set is phi. And these two straight lines having the same slope because they are parallel. If they have the same slope, they don't intersect, they are parallel, you will have no solution set. In these three examples, you will have three types of lines. Number one, the intersecting lines. So I have intersecting. In the second example, you have coincident straight lines. After that, parallel straight lines. So I have intersecting, coincident, and parallel straight lines. Now we learned how to get the solution set of two equations graphically. Let's move to another point that is speaking about getting the solution set of two equations algebraically. Or we can say that the algebraic solution for two straight lines. To solve two equations algebraically, we learned that we have two methods to solve the two equations. Number one, the substitution method and the omitting method. So we have two solutions for any two equations of the first degree. You will choose the method or the way that you will follow as you like. So you are not allowed to use any one of them, but you can choose one of them to use. Now let's move to the algebraic solution of the two equations from the two variables and from the first degree. I have 2x minus y, find the solution set of the two equations algebraically. 2x minus y equals 5 and x plus 3y plus 1 equals 0. As we said, we have two methods or two ways. Number one, the substituting method. Now we will solve the two equations 2x minus y equals 5 and x plus 3y plus 1 equals 0. The substituting method depends on having one of the two variables in one side, then have the rest of the equation in the other side, then substitute for the free variable in the second equation. From here, you can have y at one side. So we can say that if you move y here and get 5 here, so you will have y equals 2x minus 5. And this is the first equation. Go and substitute for this first equation on the second equation. If you have y equals 2x minus 5, go and substitute for y in the second equation. So you will have x plus 3y, so it will be 2x minus 5 plus 1 equals 0. How can we get this? We get this by substituting in this equation. So you will have x plus 3 times 2 equals 6x. 3 times negative 5 equals negative 15. Plus 1 equals 0. I have 6x and x will be 7x. Add the like terms. Negative 15 and positive 1 will be negative 14 equals 0. Then you will have 7x equals 14, then x equals 2. If you have the value of x, go and substitute in this equation. We can name this by the master equation. It's the master equation. So we can say that y, by substituting in the master equation, we have y equals 2 times the value of x that you got. It's 2 minus 5, so the result will be negative 1. So you have value of x and value of y. So any ordered pair consists of x and y. So we can say that the solution set for these two equations will be the set containing the ordered pair x and y. So it will be 2 and negative 1. And you are not allowed to write it negative 1 and 2 because the ordered pair consists of x first and y second. Now we will get the solution for the same two equations by using another method. It's the omitting method. So I have the first equation 2x minus y equals 5. The second equation x plus 3y equals negative 1, because in the omitting method you must have the two equations at the same order and at the same shape. Then look at one of the two variables. I have x here, the coefficient of x is 2 and the coefficient of x here is 1. You must have one of the two variables in the two equations having the same coefficient. So how can we make it x like 2x? By multiplying the second equation times 2. You will have The first is 2x minus y equals 5 as it is. Then the second will be 2x plus 6y equals negative 2. Don't forget to multiply all of the terms of the equation by 2. Don't multiply x only. Multiply all the equation by 2. Then I have two equations. 2x minus y equals 5. 2x plus 6y equals negative 2. Now we want to get rid of one of the two variables. I have 2x and I have 2x. How can we get rid of 2x? We can get rid of 2x by subtracting the two equations together. So I have a subtraction operation. 2x minus 2x will be 0. Negative y minus 6y will be negative 7y. 5 minus negative 2 will be 7. So I have negative 7y equals 7. So you will have y equals negative 1 because negative 7 divided negative 7 equals negative 1. If you have y equals negative 1, substitute in any one of the two equations, you will get the value of x. So by substituting in equation 1, you will have 2x minus y, that is negative 1, equals 5. And you must write, what will you do? So you must write by substituting in equation, like I have 1 and I have 2 in equation 1. So I have 2x minus negative 1 equals 5. So you will have 2x plus 1 equals 5. And you will have 2x equals 4. So you will have x equals 2. So you have two values, x and y. So the solution set will be the ordered pair consists of 2 and negative 1. Now you have two solutions that are the same. If you solve the equation, the two equations using the substituting method, you will have 2 and negative 1. If you solve the two equations using the omitting method, you will have 2 and negative 1. So the two methods leads you to the same solution. So using one of them is not important. You can use the way or the method that you are comfortable with using it. Okay. Now we will move to another point. We have finished the algebraic solution. Let's move to another point. You must learn that any lesson in math must have a live application. Or you must know that any lesson that you learn in math must be used at your real life. So you must use your math in your real life. You must have a real life math. Now we will use solving two equations in two variables and solving some real life operations or real life problems. Like this equation, I have the first problem. If the sum of ages of Ahmed and Osama is now 43 years, and after 5 years, the difference between both ages will be 3 years. Find the age of each one of them. So if you have a problem like this, someone gives you a puzzle to solve, and you have a puzzle like this, Osama and Ahmed having ages now 43. After 5 years, the difference between their ages will be 3 years. How can we know the age of Osama and the age of Ahmed? First, you will form the equation representing the sum of ages of Ahmed and Osama. Before forming the equation, you must have some variables representing the age of Ahmed and the age of Osama. So let the age of Ahmed x and Osama y. The sum of their ages is 43. So you have x plus y equals 43, and this is the first equation. After that, after 5 years, when your age is now 20 years, after 5 years, where your age will be 25. So you will add 5 to your age now. After 5 years, the age of Ahmed and Osama will be, after 5 years, will be x plus 5 and y plus 5. So he said that after 5 years, the difference between both ages will be 3 years. So x plus 5, this is the age of Ahmed after 5 years. minus the age of Osama after 5 years will be 3 years. So you will have x plus 5 minus y minus 5 equal 3. I have 5, we'll go with negative 5, so the equation will be x minus y equals 3, and this is the second equation, it's number 2. The first equation is x plus y equals 43. If you add the two equations together, this one, if you add them together, you will get rid of y. So you will have 2x equals 46, and x will be 23. If you have x equals 23, you will substitute in one of the two equations, like substituting in equation number 1. Substitute in equation 1. And you must write what will you do. So you will have x equals 23. So you will move put 23 plus y equals 43. So you will have y equals 20. So you can say that the age of Ahmed is x and the age of Ahmed will be 23. So Ahmed's age is 23 and Osama's age is 20 years old. Okay, let's move for another example. I have the sum of two numbers is 12 and twice one of them is more than the other by 3. So find the two numbers. I have a puzzle says that the sum of two numbers is 12. From the first sentence, you must learn how to change your English into math. You must translate your sentence. Learn how to translate your sentence from English to math. I have the sum means that you will add two numbers, let the two numbers x and y. So translate, it's a translation only. Let the first is x, second is y. I know that you have a problem with the word problems. All of you have a problem with the word problems, but try to translate, try to write what you understood from the exercise. I have the sum of the two numbers. I supposed that the two numbers is x and y. The sum of them is 12, so translate. X plus y is 12. Change English into math. This is the first equation. After that, one of them is more than the other by 3. If you see more than, less than, exceeds, increase, it will be translated into the difference between the two numbers is like this. So I have one of them is more than the other by 3, so the difference between twice one of them is more than the other by 3. So twice one of them, choose any one of them, twice x minus y will be 3. This is the second equation. It's very easy. Try to solve it. So the most difficult step is forming the two equations, and it's not difficult because only translate English into math. After that, using the omitting method, you can add the two equations together. So you will have 3x, add 3x, y will go with negative y. The sum will be 15. So you will have x equals 5. Substitute in one of them. So we can say that by substituting in equation 1, you will have 5 plus y equals 12. So y will be 7. So the two numbers are 5 and 7. Let's move to the last point in our lesson today, and it's very important remark. Now we will learn how to know the number of solutions of any two equations without solving the two equations. And this question is probably will in the choose a question and in the complete questions. As we said, in the graphical solution for the two equations, here we have only one solution for the intersecting two straight lines. So I have here one solution. Here I have how many solutions do we have? We have an infinite number of solutions because any point on the straight line is a solution for the two equations. So you have an infinite number of solutions. In this example, you will have no solutions because the solution set is fine, because you don't have any intersection point between them. So the number of solutions in the first is 1, the number of solutions in the second is infinite, the number of solutions of the third is 0. So we can say that. What do you notice about this? I have the slope of the two straight lines are equal, so we can say that the two straight lines are parallel, so the number of solutions is 0. These two straight lines are congruent, so we can say that the number of solutions is infinite. These two straight lines are intersecting, so the number of solutions is 1. Let's move to another point. I have to know the number of solutions of the two equations without solving the equations. First, put the two equations at the form ax plus by equals c. Then compare between the coefficients of x and y, or the two variables, whatever the two variables, and the absolute term. So I have, in the first example, I have x plus 2y equals 1 and 2x plus 3y equals 12. The two equations are on the shape or the form ax plus by equals c. So I have the coefficient of x here is 1, the coefficient of x here is 2. The coefficient of y here is 2, and the coefficient of y here is 3. If we get the slope of the first straight line is negative 1 over 2, negative coefficient of x over coefficient of y. The slope of the second equation, m equals negative 2 over 3. We have two cases for the slope. If the two slopes are equal, we can say that the two straight lines are parallel, so we can say that the number of solutions is 0. If the two straight lines are perpendicular, so the product of their slopes equals negative 1. Let's see. What is the case of these two slopes here? I have negative half and I have negative 2 over 3. If you multiply them, you will get m1 times m2 equals negative half times negative 2 over 3. So it will be 1 over 3. So 1 over 3 is not negative 1. So we can say that the two straight lines are perpendicular, and we can say that the two straight lines are parallel. So we can say that if the coefficients of x and y are not equal, or the coefficient of x here, its multiple here is not, so we can say that the two straight lines are intersecting. So the number of solutions is 1. So the two straight lines are intersecting and the number of solutions is 1. Let's move to another point. I have 2x minus 3. You will understand more than in this example. 2x minus 3y equals 6 and y equals 2 over 3x plus 3. The first equation in the form of ax plus by equals c. The second equation, let's multiply by 3, so it will be 3y equals 2x plus 9. Let's have 2x minus 3y equals negative 9. And here I have 2x minus 3y equals 6. If you noticed, you will find that 2 and 2, this is the coefficient of x. The coefficient of y, negative 3 and negative 3. The only difference is the constant or the absolute term. So if you have the coefficients of x in the two equations are equal, the coefficients of y in the two equations are equal, but the only difference in the absolute term, so we can say that the two straight lines are parallel. So we can say that the two straight lines representing the two equations are parallel, so the number of solutions is 0 because the two straight lines are parallel. Let's move to the third and the last example. I have 4x minus y plus 7 equals 0, so will be 4x minus y equals negative 7. And here I have 2y, negative 8x plus 2y equals 14. If you divided the second equation by negative 2, you will get 4x minus 2y equals negative 7. And the first equation, 4x, no, it will be 1. So I have, this will be ignored. It will be 4x minus y equals negative 7. And here I have 4x minus y equals negative 7. I have the two equations are the same. I have 4x minus y equals negative 7 and 4x minus y equals negative 7. If you compare between the coefficients of x and the coefficient of y, the absolute and the absolute, you will find that I have here 4 and here I have 4. I have here negative 1 and here I have negative 1. The absolute is negative 7, the absolute is negative 7. So the two straight lines are represented by the same straight line. So we can say that the two straight lines are coincident. So we can say that the number of solutions is infinite. So we can say that you can know the number of solutions without solving the equations by comparing between the coefficients of x and y in the two equations and the absolute term. Now we finished the first lesson. It's about the algebraic and graphical solution of the two equations. Inshallah, we will have the second lesson and the first session. And assalamu alaikum wa rahmatullahi wa barakatuh.